So in this section, we're looking at day 2 of piecewise functions. We're going to start out with, it says one of the most recognized piecewise functions is the absolute value function. So this is our absolute value. We're going to start out with how can we write a rule for an absolute value equation. So how can you rewrite the function f of x equals the absolute value of 6x plus 18 as a piecewise defined function? So there are different steps that we're going to do. So step number 1, we want to find the dividing point. So remember that your absolute value function, it's a V shape. We know it's symmetric on both sides. Okay? So we are looking for that point where it becomes symmetric on both sides. In order to do that, we simply take what's inside the absolute value, so the 6x plus 18. And we know that absolute value always comes out positive, so we say 6x plus 18 has to be greater than or equal to 0. It's always going to be greater than or equal to 0. Now we simply want to solve this equation for x. So move our 18 over, so we get 6x greater than or equal to negative 18. And divide by 6, x is greater than or equal to negative 3. So that's our dividing point, where x is basically negative 3. Step number 2, we want to find the domain. Step number 3 is going to be write the piecewise function. Okay. So I'm going to do both step 2 and step 3 together over here. So f of x is equal to, okay. So my domain, my very first domain, is simply what we found the dividing point. X greater than or equal to negative 3. That's going to be half of my graph. The other half, the domain, all I'm going to do is flip my inequality sign and drop the equal sign. So it's going to say x is less than negative 3. Now to get the actual function part, the pieces of it, for the first one, the x is greater than or equal to negative 3, that's always going to be exactly what was inside my absolute value. So 6x plus 18. But remember that now the other side of that, I'm looking at all the negative values. Okay? Again, when they come out, they're positive, but they started out being negative inside. So all I have to do is take what I started out with inside absolute value, the 6x plus 18, and change the sign of everything. Take the opposite or the negative of each of them. So the opposite of 6x, negative 6x. The opposite of plus 18, minus 18. So that is the absolute value of 6x plus 18 written as a piecewise. And then the last step, we're going to graph it. Okay? And we're going to go back to when we first learned how to graph piecewise. Sorry, an absolute value. We are used to it looking like this, ax minus h plus the k. That's the form we want to get it in. So I look at in here, the 6x plus 18. I don't want a number in front of x, so I can factor that 6 out, and then I get x plus 3 inside. We want that number to be that a out front. So it comes out as 6, absolute value of x plus 3. So this is what we're graphing. We remember our parent function just looked like the absolute value of x. We started with the xy table of our parent function. I was picked negative 2, negative 1, 0, 1, and 2. The absolute value of negative 2 is 2, 1, 0, 1, and 2. Now I need to make these transformations. So with my x value, it was x plus 3. It always comes out opposite, so x minus 3. The 6 gets multiplied by my y, so 6y. There's nothing being added or subtracted out here, so that's it. So I take each of my x values from my parent function and subtract 3. So negative 2 minus 3 gets me negative 5. Negative 1 minus 3, negative 4, negative 3, negative 2, negative 1. I take each of my y values and I multiply by 6. So 6 times 2, 12. 6, 0, 6, and 12. Plot these points. So negative 3, 0. That is our dividing point. So then negative 2 was up to 6. Negative 4 was up to 6. And remember that it is a V shape. So that is just reviewing how we learned to graph the absolute value functions here a while back. So now, next page, we're going to look at more rewriting the function as a piecewise defined function. So number 2 says f of x equals absolute value of negative 5x minus 10. Again, find my dividing point. So I just take what's inside absolute value, negative 5x minus 10, and I say that has to be greater than or equal to 0 because it has to be positive. I'm solving for x, so add 10 to both sides. Negative 5x greater than or equal to 10. Divide by negative 5, right? We have to remember our rule from Algebra 1 days. Anytime I divide by a negative number, I flip my inequality sign. So instead of saying x is greater than or equal to, now it's x is less than or equal to negative 2. So now I want to write my domains and my function. So the first one, what we just found, x is less than or equal to negative 2. And then to get the other one, remember I flip the inequality sign and I drop the equal sign. So it's going to just be x is greater than negative 2. The first one is always what was exactly inside my absolute value. So negative 5x minus 10 is that piece. The second one, I always take the opposite of this. So the opposite, I have the opposite of negative 5x is 5x. The opposite of negative 10 plus 10. Okay. So now we're going to look at number 3, do the same thing. So I start out with what's inside absolute value, x has to be greater than or equal to 0. There's nothing to solve there. So I'm ready to write my function with my domain. My first domain, x greater than or equal to 0. Then I flip the sign and drop the equals, so x is less than 0, my second domain. Now this one, we have a negative out front and a plus 3 out here. The negative out front just goes with the negative x. So this first one I cannot, what was inside absolute value of x? But then I have to take the negative of it because my original function had negative. So negative x, and then this plus 3 will never change anything on my function. So now the second one, I take the opposite of what was inside absolute value. So I have this negative x. I'm going to do the opposite of that is just positive x, but my plus 3 stays the same. If it's outside being added or subtracted, it just stays the same. So that is writing absolute value as piecewise. So now we want to look at this. It says a blank function. This is a step function, or also called a staircase function because once it's graphed, it looks like a staircase, a bunch of steps. This is a type of piecewise function that contains all constant pieces. A step function is discontinuous. It pairs every input in an interval with the same output. So discontinuous just means that I cannot draw the graph without picking up my pencil off the paper. Continuous, I could draw forever. So like this is continuous. I could draw this. I never have to lift my pencil. Discontinuous, there's pieces to it. So maybe I have this part, but then I have a part up here. Right? I cannot get from here to here, that piece, without picking up my pencil. So we're going to look at word problem first. The shipping cost of items purchased from an online store is dependent on the weight of the items. The table represents shipping cost y, so these are my y values, based on the weight x. These are my x's. Graph the function. What are the domain and range of the function, and what are the maximum and minimum values? So this first one, for every x between 0 and 2, 2 included, my y is always 5. So that's just the horizontal line at y equals 5. So basically, I'm plotting this ordered pair and this ordered pair. So 0, 5 and 2, 5. At 0, it's an open dot because there was no equals sign underneath there. So 0, 5, open dot. And then 2, 5, close dot. And then I just want to connect the two. The next one, let me see if I can change this and make that a little bit neater. Okay. So 0, 5 is open, 2, 5 closed, connect. Okay. So then I move on. I have 2, 8 and 4, 8. So over 2, up 8, extend my graph. So 7, 8, 9, 10. So let's see, over 2, up 8, open, 4, 8, closed. connect. I'm going to erase this so we can see our graph. And then now here I'm doing 4, 11, 6, 11. So over 4 up 11 is open. 6 up 11 is closed. Connect. 6, 14 is open. 8, 14 closed. So that is our graph. And it's called a step function, right? Again, it looks like staircases. They look like steps. My domain, I can pick my domain from my x's up here. The 0 was not included, so it's parentheses 0. I go to 2, then I pick 2 back up, go to 4. Everything's included now from 0 to 4, all the way to 6 and to 8. So 0 to 8. 8 is included, so it's a bracket. My range, I only have 5, 8, 11, and 14. So I have to write them separate, all with brackets. So 5, bracket 8, bracket 11, bracket 14. My minimum value, that is the lowest or the smallest y on my graph. Right? I can see here, these are my y's, so I can get it from my table as well. So my minimum is at 5. My maximum is my biggest y value at 14. So the last page, we look at more examples like that. So this is the word problem they give me this time. The table below represents fees for a parking lot. Graph the function. What are the domain and range? What are the maximum and minimums? Right? I can go ahead and find my domain, range, minimum, maximum, everything before I even graph it just by looking at my table. My domain, I see my x's, and time x, cost y. So starts at 0, not included, so parentheses. I go all the way up to 12, which is included, bracket. My y's, I'm going to have a 10, a 15, a 20, and 25, all in brackets. My minimum is my smallest y value, so that occurs at 10. My maximum, my biggest y value, occurs at 25. So now I want to plot these. So from 0 and 3, I'm at 10. So 0, 10, so 0, 10, open, and then 3, 10, closed, and I connect them. Then I go 3, 15, open, 6, 15, closed, connect. Then we go 6, 20 is open, 9, 20, closed, connect. And then finally 9, 25. So 9, 25 is open to 12, 25, closed, connect. And there's our graph. Our last one, this is another piecewise function, but it doesn't give it to me in a table or a word problem. It just looks like our regular piecewise. I just noticed that 4, 2, negative 3, I don't have any x's there. So again, these are my constant pieces. Okay, so I know it's going to be a step because I don't have any variables. So they're just going to be horizontal lines. Again, I can get my domain by looking at these, or I can go ahead and graph it first and then pull my domain off. So if I graph this, I'm going to start at the top with a 4. My x values are between -4 and -2. So basically, I'm plotting the points -4, 4, and -2, 4. And then I'm going to connect them, both closed circles. So -4, 4, closed. -2, 4, closed, connect. This next one, I'm plotting the points -2, 2, and 2, 2, but they're both open circles here. So -2 up to open, 2, 2, open, connect. And finally this last one, so we're going to plot the point 2, -3. It is closed, and 4, -3, closed, and connect. So I can look at my domain, my smallest x value that I have on my graph, -4, which I also see is up here. It's included, so bracket -4. I go from -4 to -3, pick -3 back up, and go over here to 2. But down here, the 2 has closed, so it's still included all the way up to 4. So my domain, -4 to 4, all in brackets. my range, again, these are my y's. They're each going to be in bracket. So -3 bracket, 2 bracket, 4 bracket. My minimum value, that's my smallest y value, that's at -3. My maximum, my highest y value at +4. So that was absolute value, writing them as piecewise, and also the step function. Let me know if you have any questions.